Hello and welcome, and this is my talk about one-shot features or the reality of agentic workflows, or how we leveraged agentic AI in our work to accelerate a greenfield project to launch. And I'm János Molnár, so nice to meet you. So I'm part of the FormNow team, and you might have a logical question of what is FormNow, and it's the new product that I mentioned. It's a 3D printing service bureau product, which means that you upload like 3D models and select some like configurations of like what kind of materials you want, and we print it with our printers and get it shipped to your house door, whatever. And it's been kind of 8 months when we started this project from ground up, and 90% of the code base is written by AI, and there's a caveat that it's 2-3 months. So there was a kind of longer bump up of the numbers of like the percentage written by AI, which is, first we generated a bunch of boilerplate. Everyone knows that AI is pretty good at generating boilerplate. But after that, it kind of started to suck, because mostly the chat and autocomplete features we tried to use kept forgetting how to do stuff, what is the technology we are using, and so on. So there's a quick fix for that called context. Context is basically a bunch of information you slap in a file, but the AI has to like kind of keep it in memory. So you just put a bunch of memory to its head, and then it's kind of analogous to onboarding a new colleague. You wouldn't expect your new colleague to just sit down and start typing and produce quality work. So you have to also explain to AI what is your standard stack, how you do stuff, and so on and so on. So models are only as good as the context you provide to them. So this is not any magic or whatever. You just have some markdown files, and you just slap instructions into the markdown files. There's some standard formats. Some bots even read others' formats because they want to be more clever. And it's written in plain English. And actually, Andrei Karpathy from Tesla started to say that the hottest new programming language is English, because nowadays with LLMs you just do plain English and it turns it into code. So what goes into the context files? General stuff: tech stack, language, framework, versions, coding style, architecture. On the architecture side, I think it's good to pick some like already existing well-known architecture, because there's a lot of resources on it, and it kind of keeps AI in like good boundaries, so it doesn't do like dumb shit or less spaghetti code. Engineering principles is also kind of useful, so you can try to tell it to not repeat code, and then it will behave or not. But I think it can be helpful. Or quality gates. Some important ones are like, don't try to deploy from my local machine to production because we have other systems for that, or other like security measurements, accessibility. Accessibility is another good one, because actually AI uses accessibility tags a lot. So if you make your website more accessible, there's more chance that the AI agents and ChatGPT will recommend it to other people. So it's kind of like good for show, SEO. So now we've had a lot of instructions, and it's a bit better, I guess. It doesn't suck that much, but now it still doesn't know how to do stuff. It cannot debug my local environment, and so on. So how can I fix that? There's something called MCP, which is, I think, pretty popular term. Again, it's not super magical. It's just a protocol, or a client-server protocol, rather, that is a standard way for agents to use external tools. Basically, you can think of the chat window running as the client, and it will go to some server, which I will explain what kind of servers there are. The server will say, hey, you have this kind of tools that you can use, which can be files or remote procedure calls or prompts, which is like, you can have like this function call and this schema, and you can list flights with this or whatever you want. And for example, I can type in something like, hey, fetch the design from Figma and upgrade my front end, and it will look up the front end, the Figma design, take a screenshot, try to understand it. It can fetch the CSS values and whatever, and we just connect it with your code. And the configuration is like not that hard. In VS Code, for example, you just slap in 4 lines of like JSON. there's a bunch of MCP servers already existing for Figma, Playwright, Storybook, Sentry, whatever you want. And for example, this is our e-commerce system, and this is my chat window talking to another AI agent, asking it like how to do stuff, and it just returns like documentation. Hey, this is how you do it. And this is me asking it to update the front end from Figma. It took some like screenshot and then connected that, hey, I need to update this component because that's the source code for that, and then it can update the test files and so on. So there's another something, because you have the tools, but it kind of doesn't know how to use it. And there's something called skills, which is a kind of new iteration on the context instructions, which is just a markdown file again. But there's interesting stuff here, which is the header, and there's some description, and basically the description is loaded only, and it kind of lazy loads the rest. So when it encounters a problem where it tries to, like, let's say I'm trying to generate PDFs, it knows that it has instructions to do it, but it didn't load it to the context or memory. It's not to pollute the memory, that's why it's done this way. And at the moment, it will read the file and then see how it can be done. And you can also add scripts and bundle it together with this kind of skills. For example, for generating a PDF, you can have a Python script, and the skills are just like basically instructions of like commands to call it. And it's pretty useful for stuff that you use sporadically, which is like end-to-end tests. You don't have to know always like what is the page object model. You can also use it for Docker, Kubernetes stuff. Maybe you don't update the deployment files every day. If you're DevOps, then it sucks for you. But for DBA stuff, you can also use it. And nowadays there is like websites for kind of like package managers for skills. So you can just find skills there for stuff that was already written by someone. And there's a meta skills, which is for finding skills. So you have a skill for finding a skill. I don't know if it's a good idea, by the way, to let AI agents download just some random skills they find on the internet, which can contain scripts. Anyways. So we are getting better, but we need to go faster than that. And what we realized is that AI is pretty good at vibe coding. Vibe coding feels amazing. And we can just vibe code a lot of tooling. For example, this is something that I wrote, which is fetching Jira issues that it can kind of identify that are easy to solve. And it's just dispatching a cloud agent, so I don't have to run it locally. It will run on the cloud and make a pull request for me. And this is what it does. And it's a small, like, literal 2-liner change, nothing fancy. But it created for me a screenshot, so that was all done by AI. And now I can see that the task was to update this header. I think it kind of looks shitty. I checked it out, and then in my local, in a better resolution, it didn't look that bad. And I just merged it. And I know it's a simple task, but you can avoid death by 1,000 paper cuts with this. If you just have a fast refactor ID, just launch an agent and it will do it, and then just accept the pull request. There's Dora, the front-end context explorer, which is just something to look at. Yeah, it's a stupid joke. Yeah, so it just helps you like see the front-end state. There's this debug panel, which is like we got tired of like uploading files to test our flows. So it just has a test like cart item basically that we just inputting here. And also we have a Slack bot, for example, that is whenever you get something deployed, it pings you on Slack, and only ones who were like impacted, who had commits in the batch that was deployed. And also the summary is done by AI as well. There's a bigger one. I think it was like a multi-day project, but we had a problem where we were running in Kubernetes, and we had like Docker Compose stuff, and not everything mapped to the Kubernetes environment. So now we have a local environment. It's using Tilt, but whatever, you have other tools like Scaffold. But basically now I can have like almost exact mapping of like what's running in production. So it's much closer to that. We also have distributed tracing, which is basically I can see where on which path the requests were traveling, And even it works across microservice boundaries. So you can see that it traveled from the e-commerce backend to the manufacturing backend and so on, and it traveled back, and you can even see like the stack traces. So it's pretty useful for debugging when you just have like some error, like where it happened. Yeah. So we are getting better, and now it generates a lot of code, and it's pretty good at it. And we don't write that much code, but it still sucks when there's like complex problems, when you don't really know, there's uncertainties. So what you can do? Well, you can kind of try to plan more and try to define your problem better and chat about requirements. You can do it with AI as well. You don't need a human for this. And you can research solutions, and it will actually give you multiple options, and you can kind of try and talk with it to evaluate which is better or worse in whatever ways. And it can also like split out like beautiful ASCII diagrams. And then once you are there, you can just go to the implementation phase. So I don't know, that last couple planning parts sounds a lot like programming pair programming to me, with some caveats that when you are doing with a human, there's a driver, navigator, and you kind of swap roles if you are doing like ping-ponging or something. With the AI, it's almost always the AI who is like writing the code. You are the navigator, kind of, and you only swap roles if the AI is doing dumb shit. And it sounds a lot like pair programming with someone who's on drugs. So the process, he does not sleep ever. You can, like, they can code at insane speeds, and they have no shame whatsoever to implement the dirtiest hack to solve your problems. But it has, as you may imagine, some cons as well, which is you lose all that stuff that Nico talked about, which is kind of sad, the human interactions and building trust, though you can still, I think you still kind of have to build trust towards AI as well, so that's part of the story. But yeah, it has crazy, crazy ideas. You will, it will always say that your ideas are fucking amazing, but they are not. And it will also never challenge your assumptions, which is kind of misleading, I guess. So everything feels great now that we implemented all of this into our work. Now we are like doing faster features than ever. What can happen now? And I think I owe you a kind of a small disclaimer is that, yes, this is web stack, this is greenfield, and it's very ideal for AI. So I'm not sure like everyone who implements this will have like all the same results. But you have to keep in mind that it was a 8-month kind of period for us. And even in the meantime, the AI got like so much better. And every year there's like a doubling of parameters. Parameters are kind of translating to complexity the AI can handle. And we went from something like this, it's a monthly time span of like request span, to this where we are spending 4 engineers credits. We can do it because not everyone is using in the company, so we can kind of steal their credits, but don't tell it to anyone. Yeah, so we are shipping like literally features, multiple features every day. What can happen now? We are like unstoppable. Well, there's something called the review bottleneck, which is a problem when you are like writing too many features too fast, and it's hard to even review those pull requests. So in the last 30 days, we merged 150 pull requests. It's roughly 3-4 engineers. That's more than 6 pull requests every day, business days, and it's 3 hours to review each this pull request every day. If you count an average review time of 30 minutes, which is, I think, little even on the lower side, because there are multiple iterations. And meanwhile, you do your work, you create features, and also have meetings and stuff. So what can you do about this to have a bit better experience and kind of overcome this review bottleneck? So there's a very human way you can solve this, which is make better pull requests. As an author, what you should do is like small changes, have descriptions, like help the others understand what you are trying to solve, and solve just one problem. Don't sneak in little refactors and stuff. Test instructions help, and I think like it's very underrated to put like videos and screenshots into your pull requests, it helps a lot to understand what was the reason you did this. So don't do this. It's also me, by the way. It's Boy Scouting, and I just changed a bunch of stuff. And also don't do this, where you are having like a feature, and like I think out of the 5, there's only one block which is actual feature. All of the rest is refactoring. I'm not saying you shouldn't refactor. I'm saying it should be in a different pull request. So yeah, I see like 6,000 lines and like another 4,000 removed. Looks good to me. YOLO approved. And there's a subtle hint that GitHub is giving you when it cannot load your pull request. Then it's kind of sure that you should break it up to smaller ones. And yeah, as a reviewer, I think you should prioritize heavily to review each other's code. I would say you should stay like in a one-day SLA, so every day basically review pull requests. If someone didn't review your pull request, then just raise it, and they should do. And also, I think clear feedback is important. So you should indicate whether it's a must fix, whether it's a nitpick that you are like fine with, if the other takes it or leaves it. And you can like play around with wording to make it better understandable. What is the point of your saying and how critical it is. So I think as an author of pull requests, you should remember that it may be generated by AI, but you are the sole owner of it, and you should make sure that it's not AI slop, or your teammates will stop trusting you. And as a reviewer, you are the last line of defense, so if AI slop comes your way, just say the famous words. And other ways to speed up reviews is quality gates, which is linters, type checkers, formatters, basically letting the machines catch what they can. The AI can generate a bunch of these linter configurations, either on your local pre-commit hooks or on the CI. This is, for example, an ESLint rule, which we like the at imports, the alias imports, and this just replaces all of them when the pre-commit or the commits run, and you can write it with AI. We didn't do anything. It was created by Copilot. There's AI review tools. There's one we really like, which is called Rabbit. I think it has a 2-week trial if you want. And I'm not paid by them. But yeah, it can give pretty meaningful review comments. Of course, sometimes it has bad comments, but generally speaking, it's pretty good. It can also summarize your pull request. There's other ones like Copilot and GrabTile. Look around, and there's something I noticed that is pretty useful, which is pull request stacking, basically stacking features on top of features, which there are tools for, like Graphite or Charcoal, which will help you even like update the pull request with like what is the dependency tree, and when it changes, it helps you like restack or rebase your branches, and also it will update the dependencies as well in your pull request. So this is much helpful for breaking your big changes to small ones, if they are like dependent on each other. So what changed since we don't code anymore? Well, before that, there was like, let's say, a project, 2 weeks. I spent like half of it on planning, half of it on implementation, and you know, it overflows a bit as usual. But eventually it gets done, so I'm happy, everyone is happy. And what's coming after the changes when we are not coding but letting AI do the job? And honestly, I worked at some startups, and I'm kind of used to like, you know, short timelines in projects, or let us say unrealistic timelines. But what happened is that we started to complete projects in 1 week, which was amazing. It felt powerful, like I have some superpower to do stuff in time. I felt successful. I got promoted. I got Employee of the Month promotions as well, and now I'm successful and living a great life. Well, as you may have guessed, none of this happened, but now I get 1 week for my project. So you might be wondering, like, was it still worth it? I think so. Because like, I can get to work on the interesting part of the work for myself, which is architecture, code flow, data models, maintainability, the user experience. And I think creative work and collaboration with the humans is even more important before, because the implementation phase being cut, it's much more planning, and I think that's where really a lot of smart guys can collaborate and have this kind of flow where we are throwing ideas at each other. So as a closing thought, I think pair programming for code writing may fade, but planning and thinking together remains essential. So thank you. And we're actually seeking people to this team. So if you liked how we work, then you can apply. And if you are pleased by that design, we're also looking for a designer. Thank you.